Hello, everybody. My name is Ryan Powers. I'm going to be coding through the LeetCode Top 100, and I hope that a lot of you will be joining me. This is my first video, so hopefully it goes smoothly. But yeah, so the first problem on the LeetCode Top 100 is twosum. So we'll be starting with twosum. So given an array of integers, return indices of the two numbers such that they add up to a specific target. And this is important here. So we're looking for the indices, not the two numbers, right? Like, so it says target is 9, then we would be looking for 2 and 7. So we're not returning 2 and 7, we're returning 0 and 1, because the index of 2 is 0 and the index of 7 is 1. Right? So you may assume that each input would have exactly one solution. So we don't need to handle any edge cases here. Each input has exactly one solution. So we will find a solution. So we don't need to handle, the edge case where the solution does not exist. And we can only use the same element twice. Just a second. Okay, so we can only use this. We may not use the same element twice, right? So if the target was 4, then we cannot use 2 twice. We cannot say 2 plus 2 is 4 because that is at the same index. So how would we go about solving this problem? So there are two solutions to this problem. There's there's an order n squared solution to this problem, which is the quote-unquote naive solution to this problem, which is one of my favorite terms, naive solution to a problem, because usually the first solution that I always come up with when I do an algorithm is the naive solution. And then there's an order n solution to this problem. So first we'll take a look at what the n squared solution to this problem would be. So welcome to my whiteboard. Apologies for the handwriting. It's actually really hard to write on these computer whiteboards with the mouse, but I'm going to do the best I can. I might try to come up with a better solution if I actually end up doing 100 videos, which I hope to do. But for now, this is the best I can do, so bear with me. So the n squared solution to this problem. So how do we go about solving that? All right. So we would first look at the value 2, and we would just go through the array, and we would look at every single value for that particular number. So for 2, we compare it with 7. We'd add it with 11 and 15, and we would say, okay, no, that does not equal the target. And then we would move on to 7, and we would look at every number after 7. We wouldn't have to go back and look at 2 because we already compared 2 with 7 when we iterated through with the value of 2. So we just need to look at the numbers after 7. So we'd look at 7. And we would compare with 11. Okay, 18 does not equal the target. Then we'd go through and we'd look at 15. We say, oh, great, we found it. 7 plus 15 is 22, and we're done. All right, so that is an order of n squared algorithm. And why is it n squared? Well, it's n squared because for each item in the array, we have to iterate through the entire array again. Now, we don't exactly have to iterate through the entire array again. If we had iterated all the way through, then we would have had another call here. And if you look at this, an n squared algorithm would look like this, right? So we would have 4 calls for each item in the array, right? So that would be 16 total calls or operations. In this array, and in this we only have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. Right? We only have 8. So what is that? That's actually n squared over 2. Okay, so if we would have had 8 items in this array, an n squared algorithm would be 64, but in this algorithm, we would only have 32 operations or times iterating through. But when we do time complexities, we only pay attention to what is actually dictating the increase in time, right? So the main indicator of how long it's going to take to run this algorithm is this n squared, right? It's how many times through this array, where n is the number of elements in the array that we have to look at. So since 2 is a constant, as n grows, it's really going to have a really small effect on the runtime of the algorithm. So we just ignore constants. So that's why you would say this is actually an n squared algorithm. So that's a naive approach to this problem, which is the first time I saw it is the answer I came up with. But there's a better solution to this problem. There's an order n time complexity answer to this problem. And how could we come about solving that problem? And the way that you come up with this problem, and the way that you usually come up with these more efficient solutions to these algorithm problems, is thinking about, okay, what is all the information that I have? Like, because in this other problem here, I would say we're not using all the information we have, right? We're just using the number that we're looking at, and we're just saying, does this equal 22? You know, but there's more information here, and that's usually the key to coming up with these other solutions. And I would just encourage you, and I'll try to do that, point it out every time I solve a problem with you guys. But like, what is all the information we have, and how could we potentially use it? So here, what is all the information that we have? I prepared the second whiteboard in advance because erasing and then rewriting takes a long time. As you can see, my writing's terrible. But what is all the information we have, right? Okay, so we have a current value, right? So at each spot that we're looking at, we have a current value. And right now, our current value is 2. Okay, so right now the current value is 2. If we start from this index. All right, and I'll just write our indexes up here because we're going to be using them. All right. Okay, so we have a current value, which is 2, but we also can have the target value, which is 22. So we can, if we want to, and I'm just going to represent, so we can, if we want to, with the pair, is we can calculate its pair, right? So if we take the target and we subtract our current value, then we know what the number is that we need to get to reach the target, right? So at every index in this array, we know the current value, and we also know what its pair should be. So we can check and see if we've already seen that value, right? If we've already seen the pair value, then we know already what the answer to the problem is. Now, the tricky part is that we don't need the actual number, right? We need the index, okay? So we're gonna go through. So the pattern that we're gonna use here is we're gonna look at 2, right? And we're gonna create an object. Okay, that's not very good, but all right, so here's a little object here. And we're gonna store the pair values, right? But the first thing we're gonna do is we're gonna look for 2, right? We're gonna look for 2 in our object, and we're gonna say, okay, is 2 in our object? And if 2 is in our object, then we will have stored the index of its pair value. So we'll have the index of our current value, and then we'll also have the index of the pair, because we've already seen it if it's in our object, right? So the first thing we're going to do is we're going to check for 2. We're going to say, okay, is 2 in our object? No, 2 is not in our object. So we're going to calculate its pair value. So its pair value is t minus the current value, which is 2. So its pair value is going to be 20. Okay, and then at 20, we're going to store the index of 2. So the index of 2 is 0. All right, and then we're going to move on to 7. And we're going to say, okay, is 7 in our object? No, 7 is not in our object. So we're going to calculate its pair. Its pair is 22 minus 7, which is 15. And we're going to store the index of 7. So the index of 7 is at index 1. And then we're going to move on to 11. And we're going to say, okay, is 11 in our object? 11 is not in our object. So we will calculate its pair. 22 minus 11 is 11. So 11's pair is 11. And remember, we can't use the same number twice. So we would have to have a second number 11 to solve this problem with 11 as the answer. So the index of 11 is going to be its pair, which is the current value, 11, which is at index 2, which is kind of confusing, but we're not going to run into another 11. So the next thing we're going to do is we're going to go to 15, and we're going to say, is 15 in our object? And we're going to say, yes, absolutely, 15 is in our object, right? So we know that we have a solution. So the current value here is 15, and that is at the index of 3, right? So we can return the current index, which is 3, and its pair, which is 1, right? Because how did we get the 1, right? So we took 7, we subtracted it from 22, and we found the number 15, and we stored the index of 7 there. So when we ran into 15 again, we looked at it in our object, and we saw, okay, yes, we have seen a number already that when you add it to 15 equals our target value, and that value is at index 1, right? So we just grab the current index, and then we match it up with the index that we stored in our object. So how would we code? All right, so that's order n, right? That's an order n solution. Why is it order n? It's order n because we only have to iterate through all of the items in the array one time. Okay, so how would we code that up? So let's go over to LeetCode. All right, so two number sums. So the first thing that we're going to do is we're going to create an object. So create a const object. So this is the object that we're going to store all of our pair values in. And then we need to loop through the array. So I equal, not O, 0, I less than length. Okay, so we're looping through all the values in our object, and we need to grab our two values, right? So just to be really clear about what I'm doing, I'm just going to say concept our current value is at nums I, and then the pair, right? So we also want the pair. So our const pair, and I made a little mistake there. So the pair is at target minus the current value, right? So what's the first thing we need to do? The first thing we need to do is we need to check to see if our current value, if we have stored that value already in our object. Because if we stored it already in our object, then we're done, right? So let's check, and we'll say if object nums current, if object current value, and I'm going to say does not equal undefined. And the reason why I'm going to say does not equal undefined is because if for some reason we stored the number 0 in our object, and we checked and just said like if object current, and that equates to 0, that would be falsy. So we would not we wouldn't get the desired outcome that we were looking for. So anytime that we're storing numbered indexes and we're checking for truthy values, I always, if I know that 0 is a possible answer, I always use does not equal undefined, just to avoid that bug, right? So if object current does not equal undefined, then we know that there's an index there that we can use, right? So we can say object current, so object current and I. So we can return object current and I. So that would be the index of its pair and then the current value that we're on. Else, if it's not in there, then we need to store its pair value. Right? We need to store the pair value of that current number in our object. And we need to store the index of our current value under that label in our object. So we would say object pair, right? The pair that we're looking for equals I, okay? And then, so that should get us the right answer. So let's run it. I'm gonna move myself. All right. All right, cool. So that was accepted. That's great. I always like to look at the output, the more details. This is why I really like LeetCode, because I know this is kind of a simple problem, but once we start looking at harder problems, and when you're doing these problems on your own, I encourage you to look at these. Okay, so this says like 61%, right? So this is the output of all the people who have submitted code to this problem, and it gives you like the runtime of your problem. You can see where does your solution lie in all of these, and you need to run it a couple of times because I don't know exactly why, but if you run it a few times, you'll get an idea of how efficient your solution is, and whether or not you should keep trying. But this is definitely the most optimal solution to this problem. So I'm just going to run it again, and hopefully I get like 100 or something, so that we can all feel good about what we did. All right, 88.49%. That's great. You can also look at other people's code too if you want to, and see maybe how they tackled these problems by like I use this thing here. You can kind of zoom up on the best run times for this problem, and you can see how other people have attempted it. And this is basically what we did here. We said, okay, if it doesn't equal undefined, then return, I don't know, these crazy variable names that they use. Anyway, my name is Ryan, and I hope you will be joining me for the next time when I solve the second problem in LeetCode Top 100.